Good afternoon, everyone. Before we begin the session, I'd like to confirm that all the presenters are online and ready. Could each of you please unmute and briefly confirm your presence? Thank you. And there are 5 papers. For the first one is paper ID 31. It's the presentee author ND ASCII you is then charged here. Not here. Okay. I will proceed to the second one. The paper ID 38 is the author Shapati Rao here. No. Okay. For the third paper, the paper ID 26, the author Basil Wilson.
Basil Wilson is here.
Oh, okay. Thank you. And for the paper ID 97, the author Nancy Kumari.
Yes, ma'am. I am Manoj Kumar Sen here instead of Nancy Kumar.
Oh, okay. Thank you.
Thank you, ma'am.
And for the last one, the paper ID 99, the author K. Manaka. Are you here? So there are only 2 authors here, right? I noticed that in the chat room that there is a paper ID 22. However, in my session, I didn't have any information about the paper ID 22. Could you please check that do you need to enter this session or the other session, because we start our sessions, 2 sessions at the same time. Okay. Good afternoon, everyone. Welcome to this session. My name is Shiban Zhou, and I am honored to serve as the session chair today. In this session, we will have the pleasure of hearing presentations from 5 authors, each sharing their insightful research. Each presenter will have 15 minutes to deliver your talk, followed by 3 minutes for a Q&A session. To help keep us on schedule, I will give a gentle reminder when there are 2 minutes remaining in the presentation time. Thank you all for joining, and let's begin with our first speaker. The paper ID 31 is the author here, ND Ishan Shajid. If not, we will proceed to the paper ID 38. Is the author Shapachi Rao here? No? Okay, we will proceed to the paper ID 26. I just confirmed that the author Bashit Hushan here. So just take your turn and please share your slide with all of us. Thank you.
Okay, thank you. Can I start now? With my screen is visible.
Yes, you can start your presentation and maybe you can speak loudly.
Okay.
Okay.
Good afternoon, and today I am delighted to present our research optimizing transfer learning models with GradCam to improve mass disease detection. And the paper ID is 26, and my name is Basit Hussain, along with my co-authors, Malika Muradi, Christian, Ilya, Treasure, and Anijat Alim Rasul from Bright University. And let's dive into our research paper. So, why we focus on maize? As we know, maize plays a vital role in global food security, serving as a staple crop for our billions people, particularly in low-income regions. Beyond its nutritional value, maize supports millions of smallholder farmers and various industries such as livestock, feed, and biofuel. However, its production faces significant threats from diseases like MLM and MSV, which cause substantially yield losses. Developing accurate diagnostic tools is essential to combat these challenges and prevent further crop losses. So here in this tab bar chart, we can see the mass production in African continent from 2017 to 2025. As we see, the production is increasing from 2021 to 2024, but as in 2020, so 2024 and 2025, the production mass production is decreasing. So this statistical data is gathered by the statistic of U.S. Department of Agriculture. So our objective of this paper is to develop an accurate and transparent and deep learning based system to detect MLN and MSV in maize crop, evaluate and compare the diagnostic effectiveness of various transfer learning models, and use explainable AI methods like GradCam to enhance model interpretability. We have gone through a several research which has already been done in this field. So the first paper, which focuses on leaf.net for multi-species leaf diseases identification, and next paper focuses on mFaster or CNN for corn leaf disease detection, and third paper mobile is focuses on mobile system for detecting maize leaf diseases in Punjab, Pakistan, and next paper detecting mass alia diseases in complex environment, and a fifth paper is focuses on detecting a maize leaf diseases, and the next paper corn disease classification using deep learning, and seventh paper is focuses on early maize disease detection to enhance productivity, and eighth paper which discusses disease detection and classification for grapes and tomatoes, The last paper, which improving chronic diseases identification in County Kenya. Uh, Here is the research gap which we found from the previous work which already have been done. So this table is actually represent what's the gap on those works which already have been done. The single line here is represent not covered, but the double line. These two lines represent the partially covered, but the three lines represent completely covered here. So the data set less than 1000 we represented by one line, but the data set in between 1000 to 5000 images, double line, but the data set which is greater than 5000 is represented by triple line. So here we can see the mass disease analysis. Most of the paper have covered most mass disease analysis, but if we look at the MLN and MSV, which are the one of the most diseases of mass, which are most of the paper did not cover MLN and MSV disease, which our paper covered in this research. And data set which most of the papers have a data set less than 5000 images, and which we also covered in our research. And about the machine learning and deep learning models, we can see most of the paper have covered machine learning and deep learning models. But if we look at the explainable AI, then most of the paper did not implement explainable AI except the paper one, which we covered in this paper, this our research. We implement explainable AI. So our workflow starts with data acquisition, followed by labeling a data set. Then we implement image processing, image augmentation, and then we split a data set into 80% for training and 20% for testing. And then we perform different models. In this research, we use 5 transfer learning models: ResNet 50, Inception V3, which is 16, Exception, and EfficientNet V2, B2. Then we select a best model to implement explainable AI, and finally we discuss the results. And the data set which we use in our research has consist of 17,277 label image categorized into three classes, which is healthy, MLN, and MSV. So then we implement various data pre-processing techniques, resizing images to match model input requirement, normalization to standardize pixels values, and data augmentation techniques like flips and rotation to improve generalization. We used 5 transfer learning models in our research. And the first model is ResNet 50, which is renowned for overcoming the vanish gradient problem. And the second paper is Inception V3, which is excellent for multi-scale feature extraction. And third model is VGG16, which is known for its simplicity and high accuracy. And fourth model is EfficientNet V2 B2, highly efficient with faster training speed. And the last model is Exception, uh, which combines a computational efficiency with high performance. And each model was fine-tuned to optimize performance for our mass disease detection. So let's discuss the results and discussion. Here are the parameters which we set for our models. Base size of this the table shows the parameters are like a base size, optimizer, learning rate, input size, dropout rate, and loss function. So Mm, this slide shows the confusion matrix of ResNet 50 and EfficientNet V2 B2, which are the best performing models among those of all 5 transfer learning models. And we can see the EfficientNet V2 B2 perform 92% of accuracy, but the ResNet 50 perform the 91% accuracy, followed by the Inception V2, which perform 80%, but which is 16 perform 81%. and exception performs 89%. So one of the key aspects of our research is implementation of explainable AI. So we implement explainable AI because explainable AI enhance transparency and increase trust and adaptation and empower non-technical users in this field. Our non-technical users and most of the farmers which they don't have a knowledge about and AI and different machine learning and different models. So we implement one of the method which is GradCamp, and GradCamp visual explanation by highlighting the most relevant regions of an input image that influence the model decision. So here is the one of the example. We feed an input of original image in a GradCam model, and the GradCam highlights here in the second image. We can see the affected areas on the basis of which model classify this image as a particular class. So the final image, the third image, is a GradCam with a heat map where we can see the highlighted region of the affected areas. Let's the key achievements of our paper is to integration of XAI and high performance CNN models to provide a reliable interpretable framework, and the system can reduce crop losses, enhance yield, and support sustainable framing, especially in sub-Sahara Africa, and they improve interpretability with GradCamp for the models will ensure transparency in functioning of the proposed model to build trust among non-expert users, the farmers. So the future works here includes our dataset expansion, as our dataset is consists of 17,000 more than 70,000 images. But in the future works, we can expand our dataset from to, and then the second I think would be to implement a real-time monitoring technology that enhance productivity disease management in framework. And the third one is to improving explainability. We can implement more XAI techniques. In this paper, we implement GradCamp, but in future we can implement more XAI and advanced technique for further exploration in this field. These are from our side. Thank you very much. Thank you so much.
Okay, thanks, Basil Hussen's presentation. And we now have 3 minutes for the Q&A session. Are there any questions from the audience? Please feel free to unmute yourself. We'd love to hear your thoughts or feedback. Any questions? If not, I have several questions to ask. I'd like to know how to collect the data for your data set. And before applying this data set, do you have some data preprocessing process?
Yeah, we collected a data set from Nelson Mandela Institute from Tanzania. They have gathered a data set, and they already pre-processed some level a data set. We collect from the data set from there, and for pre-processing techniques we implement some of the pre-processing techniques to we found some of the images were corrupt, so we remove those images, and we standardize all the images into a fixed size for according to our model, and we also implement augmentation to balance a data set in each class.
Oh, okay, thank you. And how to handle the few data set problem for your research?
few data set. Okay, we implement a data augmentation to like our sampling our sampling the few data set to balance with a large amount the class which has a large amount, and by using by generating imaginary data by rotating and the zooming and those other techniques using.
Oh, okay. Thank you. Any other questions? If no, thanks again for Dashi Hushen's presentation. And now we will proceed to the next paper. And it's paper ID 31. The presenting author Andy ASCII Yishan Shajit here. It seems that some of the presenters are not currently online. I will call their names again to confirm. If they are still not present, we will proceed to the next presentation on the schedule. If any late presenters join later, we will try to accommodate their presentation at the end of the session, time permitting. Thank you for your understanding. So, is the paper ID 38, the author Ern Shapachira here?
Hello.
Oh, okay.
Can you hear me?
Yes, I can hear you. And now it's your turn. Please share your slide. And if you are ready, we will start your presentation. Thank you.
Yeah, just a second. I'm sharing my screen.
Okay.
Can you see my screen?
Not yet.
Just a second. It's still loading.
Okay. Okay, I see your screen.
I think I shut the wrong window. One second. Let me reshare. Sorry for this.
Okay.
You see my screen now?
Yes.
You see the presentation?
Yes. So, if you are ready, you can start your presentation.
Okay. First of all, good afternoon, everyone, and thank you for joining today. I'll be presenting our research titled An Integrated Model for Colon Cancer Detection from Histopathology Images. And to start with the introduction, colon cancer remains one of the leading cause of cancer-related deaths worldwide. Early and accurate diagnosis is really crucial to improve patients' outcome. But manual analysis of histopathology images is often time-consuming and also prone to error due to complex and heterogeneous nature of the tissue structure. So in this research, to address this, we developed and achieved comparable accuracy. It lacks the advancement feature, extracting and robustness offered by the two models, which has DenseNet 169 and GoogleNet. DenseNet excels in detecting the fine-grained details, while GoogleNet captures the multi-scale pattern, making their combination ideal for complex classification tasks. In medical imaging, robustness is critical, and small errors can lead to severe consequences, such as missed cancer diagnosis. The ensemble approach mitigates this risk by combining complementary strengths of multiple models. Beyond colon cancer, this methodology is applicable to other imaging tasks, including breast cancer detection, diabetic retinotherapy screening, and liver lesion classification, and other broader clinical impacts. And in conclusion, our ensemble model combines DenseNet 169 and GoogleNet, achieved an impressive accuracy of 88.56% on histopathology images. This demonstrates the potential of advanced deep learning techniques in automatic cancer diagnosis, reducing the reliance on manual methods and improving patient outcome. And moving forward, we plan to test this approach on larger and more diverse data sets to further validate its effectiveness. Incorporating attention mechanism could enhance future localization, improving diagnostic precision. Real-time implementation in clinical setting could revolutionize cancer diagnosis, offering faster and more reliable results. This this highlights the transformative potential of deep learning in precision medicine. And that's it from my end, and open for questions.
Okay. Now we have 3 minutes for the Q&A session. Are there any questions from you? Any questions? If you have questions, you can just unmute yourself. I have one question. From the simulation results, how can we ensure that an accuracy rate of 88.56% is a good result? Has it been cross-validated with real case data?
Okay, so we have almost used the real case data, which were of 5,000 images, which were 625 images of different types of colon cancer, and 625 images from each type, which counted to 5,000. And we have used a robust methodology. Like we see, ANN model already had 88%, but it lacks the robustness. And when it comes to colon cancer, analyzing the type of tissue which is growing in the colon, which is causing the cancer, is really important. It was lacking that precision. We can't say precision, it was already good, but our model, which is combining of DenseNet and GoogleNet, has more precision when compared to ANN models. So this paved a way for using the combination of ensembled approach, which increase the accuracy and precision, ma'am.
Okay, thank you. And any other questions? Oh, okay.
Yeah, please. Can you come again once? Which is the best? Yeah. Okay. So this is completely based upon the accuracy and precision of the model. And to avoid that loss functions, like we have made sure like all the images are of same pixel size, and probed and zoomed for same pattern all around, so that there is a reduced amount of losses and errors. That's what the functions which we have taken from our end. Yeah, like we were using the DenseNet model.
Any other questions? If not, thanks for the unsurpassing Ross presentation. And now we will proceed to the next paper, and we now will count the next author to present their research findings. The paper ID 97, and the author is Nancy Kumari.
Yes, good everyone. I am
Okay,
Manoj Kumar
thank you.
Sen. I will be present the papers.
Okay, I didn't see your slide in the screen.
Ma'am, it's loading.
Oh, okay. Oh, thank you.
Can you
please
see?
start your yes. Please start your presentation if you are ready.
Okay. Good morning, everyone. Myself Manoj Kumar Sen, and I will be present my paper. The topic is revolutionizing MRI tumor detection, a fusion of DCNN and solved from algorithms. So the overview of the presentation is, first I will give the introduction, then after that there will be some structure review, after that the problem statement and the methodology and the algorithm which we used for the implementation. After that we will discuss about the result and discussion, and the last is conclusion. So the introduction. So brain tumors are the significant health concern caused by the abnormal growth of brain cell. For the accurate classification of MRI scan is critical for identifying the types of tumors, enabling improved diagnosis and treatment planning. So we can compare to other methods like biopsies and CT scan. MRI is prepared due to its non-invasive nature and its superior ability to clearly differentiate between various types of brain tissue. In the recent year, deep convolutional neural network have revolutionized the field of medical imaging by learning intricate features from the large dataset. Models such as AlexNet, VG16, and ResNet have significantly advanced brain tumor classification. However, these models often suffer from inefficiency due to redundant features and lack of robust feature selection mechanism. We can compromise both classification accuracy and the computational accuracy. Now, here are some review for this study. In the year of 2024, the Wei et al. Proposed a method that leverages statistical moment and probabilistic techniques for the brain MRI classification, achieving high accuracy through feature extraction and dimensionality reduction using ANN. This approach also aligns with the finding of SSN integrate details data accuracy for distinguish between different type of brain tumors. Now we do the feature selection for using the sum algorithms. Basically, SSA is a sophisticated optimization framework designed to advance feature selection relevant to machine learning paradigm. Particularly when it comes to classifying brain tumor, we utilize MRI imaging. The sum algorithms mimic the coordinate moment of SARC by categorizing the population into leaders and agent, where leader guide the agent movement. In brain tumor classification, SSA integrate with deep learning models like AlexNet and VGC16 to extract features from the MRI scan and create a high-dimensional feature representation. Now this is the result which we getting after implementation. So we can, for the access the effectiveness of demonstrate framework, we use some of the performance metrics such as accuracy, precision, recall, and FN score. Now we can see here the ResNet model. Where we can achieve the high accuracy, that is 95.28, which is better than two others models. So here we can see the comparison matrix diagram, which is represent the classification result. The correlation between the actual and predicted label for different type of brain tumors are displayed in the concision matrix, which is offered through picture of the classification performance. Now this is the ROC curve. Basically, ROC curve is a graphical curve that plot true positive ratio against the false positive ratio. It is utilized to check the performance of the model. The VGC16 model training and validation accuracy curves show the learning was successful over the course of the 18 epochs. The red line represents the training accuracy with rise consistently from approximately 0.6 to about 0.95. Indicating that the model is assimilating the input well, while the validation accuracy varies at first, it studies as training goes on, finally catching up to the training accuracy and reaching about 0.9. The minor difference in the accuracy between training and validation data indicate that there may not be much overfitting and that the model is performing well in the brain tumor classification when it comes to generalizing and new data. And the last part is conclusion. So basically, this study represents a automated system for the classifying brain tumor using deep learning model, especially ResNet and VGC16, which is combined with the data augmentation and the sum algorithm for the feature selection. The approach enhances model performance by improving its ability to handle the variation in tumor characteristics and increasing the available training data. However, some challenges remain, particularly with the computational demand of SSA and the impact of the dataset quality on the classification accuracy. Also, there are some future research. So if we focus on optimizing SSA for the better efficiency and improving data quality through advanced preprocessing technique. Overall, the proposed system has significant potential to improve early detection and diagnosis of brain tumor, contributing to more accurate clinical decision making. Future research will aim to optimize the computer efficiency of the SSA and improve the quality of the dataset through advanced preprocessing technique. Thank you. That's all.
We now have 3 minutes for the Q&A session. Are there any questions?
Yes.
I'd like to ask one. As mentioned earlier, the proposed method trains various SBM models, and the SSA algorithms assist with feature extraction. Will the same features or different features be used for each SBM model?
Yes, ma'am. So, ma'am, we used for the SSA because it is the natural optimization algorithms, and it is dynamically selected the features by the balancing accuracy and feature reduction. And it is also identifies a minimal subset of the most relevant features and integrate with the classifier to evaluate subset during the optimization.
Okay, and how many features for one SBM model?
Yes, ma'am. We use Yes,
is
ma'am.
there
Yes, ma'am.
is there an exact value for the number of the features you adapt for each different or each SVM model?
Yes, ma'am. After the feature extraction, if we didn't get a number of features, so because the accuracy we get very low, so we use the sharp sum algorithm for the feature selection to achieve the better accuracy.
Okay. Okay, thank you. And any other questions? If no, thanks for the Nancy Kumari's presentation. And now we will welcome the next author to present their research findings. The paper ID 99 and the author K. Menaka.
Can I stop my sharing?
K. Menaka.
Good morning, ma'am.
Okay. Thank you. I can hear you. And if you are ready, you can share your slide on the screen. Thank you.
Yes, ma'am. Yes, ma'am. Good morning to one and all gathered over here.
I can hear you. However, I cannot see your
open.
screen.
Yes. Let me open it now. Loading. Yeah, it's not on. Can you able to see my screen, ma'am?
No, not yet.
Yes. Wait, just a minute, ma'am.
Okay.
Yes, ma'am. Yes, ma'am. Is it visible, ma'am? Yes. Ma'am?
No.
I have opened actually.
However, I cannot see your slide on the screen.
I have shared, ma'am, but it's not coming. Display over other apps it's showing.
Can anybody see the slide on the screen?
Deepan Jangar. 1 minute, ma'am. Let me ask one help, ma'am. What to do now? Ma'am, is it? Can able to see, ma'am, what I'm processing? Is it visible now? Ma'am?
Yes.
Is it visible, ma'am?
No screen here.
Is it visible now? It is visible to me, ma'am, but I don't know why it is visible, not there. I don't know, ma'am. Yeah.
Okay, now I can see your screen. The
Now is it
home
visible,
screen,
ma'am?
right?
Ma'am, is it visible
Yeah.
now? Shall I proceed,
Yes.
ma'am?
Yes, I can see your screen.
Yes, ma'am. Good morning to one and all gathered over here. Myself, Dr. K. Binayak, Associate Professor EC from Velamal Institute of Technology. Yes, ma'am. Is it audible to all? Yes, ma'am. Yes.
Yes, I can see your screen. So if you are ready, you can start your presentation.
Okay. The topic for my presentation is image processing techniques for leg bone X-ray image enhancement. I am the corresponding author, and the co-authors are P. Dharani, Aparna Mohanty, and Sumati Gokul. The outline of my proposed work is problem statement, introduction, literature survey, existing method, objective, block diagram, algorithm, data sets, and the project model, results discussion, and final references. Next comes the project problem statement. First, how can we design an image processing algorithm for portable X-ray devices, especially to reduce the noise, and we have to enhance the contrast and sharpen the image without altering any clinical diagnostic details. So this is the question we have framed for our problem statement. This problem statement includes hardware limitations and validating with diverse medical data sets for accurate clinical application. Here next comes the introduction. There are n number of images if you are taking in the image processing. For example, X-ray images, CT images, MRI scan, everything is there. The portable X-ray device has been used in multiple fields because it is of low cost, and the resolution is very low. So images from portable X-ray devices often have limitations such as low contrast, noise will be more, and the sharpness will be less. So the development of image processing techniques, especially to enhance the quality of these low resolution X-ray images by improving the contrast, reducing the noise, and we have to sharpen the details in order to diagnose a novel approach for bone fracture detection using image processing. Here they have used all the canny detection algorithms. For the classification, they have used the machine learning algorithms such as SVM, KNN, Navy-based classifier, and so on. The main disadvantage is the area of fracture is very difficult. However, they have attained the accuracy of 85%. So the overall inference from these literature, we have surveyed n number of papers because in the proposed method, we are going pre-processing steps before the enhancement process. So if we have done n number of surveys for each processing method, and the most three literature survey 1, 2, and 3, What is the major limitation is, it is insufficient to visualize the diseased portion where the fracture has been occurred. So this is what we have inferred from the entire literature survey. So based on that, as a problem statement I told earlier, we have to remove the noise, we have to enhance the image, and we have to sharpen the image. If we are doing these pre-processing steps, then the visualization will be better, and it will help the doctors to diagnose the fracture location exactly. So these are the various literature survey we have done for noise removal. Here we have categorized the literature survey based on title and the image data set what they have used. First is the detection of bone fracture based on machine learning. Here they have used the Gaussian filter and they have got the performance metric accuracy of 0.64 to 0.92, that is 64%, like this. Then when you are they have used n number of algorithms for noise removal, that is Gaussian filter, Gaussian blur, median filter, mean filter, and so on. From this we conclude that wavelet based anisotropic diffusion, the leg bone, especially the tibia, is clearly identified and the accuracy level is more, 91.27 to 98.43% on the data sets what they have used. So we have chosen these data set, so we have chosen these algorithms for the pre-processing step of our X-ray images. So like this, for each pre-processing step we have done the n number of survey papers. And next is for contrast enhancement. For contrast enhancement, the algorithms what they have adopted is adaptive histogram equalization, logarithmic image processing, contrast limited adaptive histogram equalization, and histogram equalization, it goes on. So from this we have concluded that when we are experimenting our X-ray images using CLACH, that is contrast limited adaptive histogram equalization method, we are getting the good contrast adjustments in the X-ray images. So we have chosen these for the image enhancement, contrast enhancement. Next comes the sharpening method. Sharpening method, the algorithms used in the previous surveys are edge reduction CANI and two-way segmentation entropy method. There are n number of edge reduction methods for sharpness, Sobel, Robert, and Laplacian operator and Gaussian operator. In this we have chosen the CANI edge reduction, which is widely used edge reduction method in most of the image processing algorithms. Especially in medical imaging, CANI edge provides a good edge detection. So we have chosen these three, we have confined these three algorithms. That is, first one is wavelet based and for noise removal, and second one is CLASH, contrast advanced histogram equalization method for sharpness, and for sharpening we have used CANI edge detection. So combining all these methods, the enhancement process have done nicely, and we have the good visualization at the last. So from the existing method, what is that concluded is, in the based on the survey, it is concluded that various ways to reduce noise and enhance contrast and sharpen different types of images, including the X-ray images, even though it has a lot of advantages, the enhancement results yield by the proposed method still have some insufficient visualization. That is, after applying the proposed method to all the X-ray images, still the visualization is lacking in the existing method. So that we have taken as a problem statement, and our main objective of our design is to reduce the noise, enhance the contrast, and sharpen the image without altering the clinical diagnostic, as I have already told in my problem statement. So for our pre-processing steps, we have concluded three hybrid algorithms. First one is wavelet-based anisotropic diffusion for multiscaling technique, and followed that is the CLASH algorithm for local contrast of the image in order to improve the contrast of the image, and finally, in order to, if the visualization is better, so after applying the canny edge, the edge details will be clearly seen. So this is the block diagram of our proposed work. First, we have taken the X-ray image of a leg, in which method we have applied only canny edge detection, where we got the output. Second, after applying the contrast enhancement method, that is clash algorithm for contrast enhancement, and applying that, after applying that, we have applied the canny edge. This is the output what we got. And finally, we have add wavelet based anisotropic diffusion, in which the lower frequency components, which has the most significant information, has been retrieved, and after that contrast enhancement has been applied. Finally, the canny edge is applied. So from these three images, we come to know that visualization is better in the third method, combining all the hybrid methods. So these are all the algorithm and design equations. First one is the wavelet based anisotropic diffusion, and the second one is the clash algorithm. Here in the clash algorithm, the method applies the independent histogram equalization for each smaller sections in order to improve the contrast that highlights the enhancement process. Actually, the histogram is applied to the entire image. Here, for each and every smaller sections, it has been histogram equalization is applied independently in order to improve the contrast at each smaller fine details of the image. So this helps to avoid the over amplification of noise in areas with a low contrast and making the image more visually appealing. So that is the highlight of choosing this algorithm for our proposed work. And next is the canny edge detection method. Canny edge detection method, it gives the edges, it detects the edges without any discontinuities in order to get the overall appearance of the image without distorting the boundaries of the image details. And next is the dataset table. So what are all the datasets available for X-ray image has been reviewed in our work. First is the Mura dataset. It is a leg bone dataset. And second one is a Kaggle dataset. It comprises both the leg and hand bone images. And third one is the FRAC Atlas dataset. Here for our implementation, we have used the FRAC Atlas dataset. Here it comprises of hand, shoulder, leg, and hip bones. For our work, we have considered the leg bone fracture. And the last one is a grass Ridex dataset. Here it comprises of the wrist of the pediatric, but all comes under X-ray images. So in order to confine, we have taken the leg bone X-ray images, which is the FRAC Atlas dataset, has been used for our implementation work. Next, dataset description. In our project, we are utilizing the FRAC Atlas dataset. It comprises.
Excuse me, just a reminder, there are only 2 minutes remaining. Okay, go ahead.
Yes, next we are coming for the results and discussion. So method 1, method 2, method 3. So these are the X-ray images, and where the canny edge detection output what we got, and after applying catch and canny, what is the output what you are getting. You can able to clearly see the comparing to the input image, the visualization is appealing after applying the catch and canny. Finally, we have applied weed that is weed plus clutch plus canny. Here the localization and the visualization is very appealing, which will be helpful for the doctors to diagnose the result. So these are the results we obtained from in our proposed work. So this is the simulation tool. We have used MATLAB 2019 for our simulation results. First is the input and second one is the noise. So in order to remove the noise, we have used the weed anisotropic filtered image. You can able to see the difference from the input image and the noise removed image. Then next one is the wavelet decomposition. It comprises of 4 levels: low, 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 high, high, low, high, high, where the significant information lies in the low frequency band only is used, which reduces the storage of the image, and this is the restored image in the weed. And finally, this is the enhanced output what we got. So to the restored image, we have applied the clash and the edge has been detected. So this is the final detected output, and this is the oblique type of leg fracture. It has been detected using the hub transform. So the conclusion is the portable X-ray image enhancement using image processing involves the application of various algorithms. These enhancements aim to enhance the diagnostic accuracy of the doctor, improve the visualization of anatomical structures, and aid in clinical decision making. As research and development in image processing continue to advance, the future work holds the great potential for further refinement and innovation in portable X-ray image enhancement, benefiting the healthcare professionals and patients alike. So these are the various references of our work which we have done a deep literature survey, and we have finally done the enhancement procedure for the X-ray images, especially to help the doctors to diagnose accurately. Thank you. Thank you for giving me this opportunity.
Okay, we now have 3 minutes for the Q&A session. Are there any questions? Okay. Please.
Yes, sir. So, what we have done is we can do the augmentations, sir. Data augmentations, yes, yeah. For example, if we are going, we have used the machine learning algorithms. If you are going for deep learning algorithms, number of samples should be more. So, which is not practically possible for all the image data sets. For the patient's data sets, getting is very difficult. So, we have used the benchmark data set, what is available. And some extra images we have consulted with the doctors, and we have used that also. In future, we are planning to develop the app for this, our works. It is under process, developing the app.
Okay, any other questions? Any other questions? I have one. The research involves many steps. How long does the entire process take to complete the training? Has the time complexity been considered? And also, what is the performance of the execution? Do you compare your approach with other comparison approaches?
Yes, ma'am. Actually, enhancement means they will either remove the noise, or else they will improve, they will sharpen the image, or else they will enhance the contrast. So what are all the main difficulties in the X-ray images? Noise is there, contrast will be low, and sharpness image details are not sharp. So we have taken all these issues, and we have done the 3 pre-processing steps, ma'am. If you are applying only the filters, we are getting only noise will be removed. If you are applying only the contrast enhancement algorithm, only the enhancement contrast will be improved. So each and every step by step improving, finally the doctors will get the good diagnosis of the actual X-ray images, ma'am. So whenever we are going to the doctor, first they will start with the X-ray images only, ma'am.
Okay,
so each
thank you.
algorithm we have done experimentally. After that only we have extended our pre-processing steps, ma'am. So we come to conclude that only noise removal is not sufficient to diagnose. So we can move on to next one more step. So we have gone for contrast enhancement. Then finally, the image, actually the medical data set will be of high, high size. So we have used the weed where it will be compressed to 25%. Only the significant information of the image will be there, and the high frequency components will be removed, ma'am. So it really helps the medical field in such a way. So we are planning to develop the app for this. work also, ma'am, in future. It is under process, ma'am.
Okay, and how about the comparison approach to verify the effectiveness of the proposed approach?
Yes, ma'am. Here, ma'am. So if you are taking the CANI, it has been already proposed by someone. So the next is the clutch plus CANI. Our proposed is this one, ma'am. Bead plus clutch plus CANI. So these give the good result. Can you able to see, ma'am, in the screen? Is it visible?
Okay.
Yes. So
Okay, I
after
see.
the input X-ray images, it comprises of 3 columns, and the last column is our proposed work result, ma'am. After that only we can able to look at, when we are applying only CANI edge and we are trying to locate where the fracture is occurred, we can't able to locate the exact location, ma'am. After applying the second clutch plus scanning, that also it doesn't works, ma'am. So finally applying all the 3 algorithms along with the weed, after removing the noise, finally the fractured location has been detected, ma'am. Is This is oblique fracture. Actually, the fractures are of 9 types. It is transparent, oblique, dislocated. In this, this is of oblique fracture detected using the hub transform, ma'am. So these are
Okay.
comparison results, ma'am. Yes.
Okay, thank you. And
Thank you, ma'am.
thanks for the Binayak presentation. And now
Okay, ma'am.
we will proceed to the next paper, and the next paper is the last one. The paper ID 31 is the author ND ASCII Ishan Shajik here.
Thank you for giving me this opportunity, ma'am. Thank you.
Yes, you are welcome. It's the author ND Ashaki Ishan Shajit here. The paper ID 31 with the title Augmented 3D UNet Architecture for Accurate Multimodal MRI Brain Tumor Segmentation. So again, to confirm, the author for the paper ID 31 isn't here, right? If no, we just finish the paper presentations. And thank you all for your active participation and insightful questions throughout this session. I'd like to express my gratitude to our presenters for their excellent contributions and hard work. This concludes our session, and I hope you found it informative and engaging. Enjoy the rest of the conference and have a great day. Thank you. Thank you all, and we just end our session.
Thank you, everyone.
Thank you, Professor Cho, for chairing the session. And we will start the next session in 15 minutes by 2:30 p.m. Please stay tuned.
Hello. Yeah, I'm audible. Yeah. Yeah, hello. Just a minute.
Okay, sir. Is it sharing, sir? Okay. Good afternoon, sir. I am Barani Chandar, currently pursuing MTech at VIT Vellore. It is an honor to present our work, AI-powered disease detection and classification of mango fruits using AlexNet, a farmer-friendly tool, under the guidance of Dr. Sri Haripriya Ma'am, Associate Professor VIT Vellore, and the co-authors Dr. Christopher Clement and Sonia S. At the sixth conference.
Varni.
Yes, sir.
Make it presentation mode. It's not in presentation mode as of now. Now it is fine. So all participants, please change the presentation mode when you are presenting. Yeah, continue, please.
Okay, sir. Under the guidance of Dr. Sri Haripriya Ma'am, Associate Professor VIT Vellore, and the co-authors Dr. Christopher Clement and Sonia S. at the 6th International Conference on Advances in Distributed Computing and Machine Learning 2025. Thank you for giving this opportunity, sir. Introduction. Agriculture is the practice of growing and cultivating plants and other products essential for human survival. Agriculture is one of the most growing sector across the world. It's detecting stem and rot and following the recommendation. Halton area. Black mold rot. Finally LC1. Is predicting LC. This is the web page I have developed. Shown the result. This only I mentioned as a result there. In future, I try to develop Android applications. This is the demo for that. I will apply not only in fruits. I will work on vegetables also for all kinds of vegetables and fruits with various kinds of diseases. This is a future work of our project.
Okay, Varni. One question I have.
Okay, sir.
What is your main contribution in this entire project? What the main effort you have put it on? Because I can see the data you have taken from Kaggle, right?
Yes, sir.
The model is pre-existing, that is AlexNet,
Yes, sir.
right? Then what is your contribution?
By collecting the data set from Kaggle,
That is not a contribution, right? Data is already there.
Yeah, sir. I pre-processed the data with the different
So that is
data
a
machines
contribution? Pre-processing
and
is a contribution?
Sir,
developed the web.
sir, I'm one of the co-authors. Can I answer for this
Mm-hmm.
question?
Yeah,
Sir,
please.
can I answer for this question? Yes, sir. Actually, what we did here is we just taken the data from Kaggle. So here we demonstrated by using a classification algorithm, that is AlexNet. We identified and created a farmer-friendly tool. So that is the main novelty. We are working on it to further vegetables or any other fruits also, sir. Here we are identifying and classifying which disease affected selected fruits. That is the main novelty.
So the disease you are mentioning at the end of predictions, that disease suggested by some professionals, or it is also written somewhere?
We have newly created this one, sir, web page and.
No. I'm not asking the web page. It is fine, the web page. I'm asking against a particular disease, there is some precautions, suggestions you are giving, right?
Yes, sir. Yes, sir.
So that suggestions, how it was developed? It was developed by you or developed by some medical expert?
It was developed by the agricultural university, the nearby agricultural university.
Yeah, just prediction.
So lots of things actually you have to take care if you are really interested to continue with this work. Think about it, what is the major contribution and how exactly going to be help. The first thing, the suggestions that you are giving at the end of predictions, that must be properly verified by some expert on that particular field. Otherwise, what is the suggestion, whether the suggestion is going to work or not work for the farmers, that is a major concern. Okay. So suggestions play a vital role here. Moreover, why only one suggestions? Maybe other suggestions can be also listed. Instead of one suggestion, a farmer can be suggested with more than one, if possible. So if not a major contribution towards the building the model, a contribution can be developed on this particular side. Otherwise, look like the good work. Okay.
Thank you, sir. Actually, the suggestion has been applied based on the fruits from the agricultural university professors who have worked on. From them, we have received the suggestion. We'll take your suggestions and we'll add few more details.
Yeah. Thank you.
Thank you, sir.
Thank you.
Now the paper ID 16, 16. No one? Paper ID 67?
Yes, sir, we're here.
Yeah, please.
67.
You can share your screen.
Okay, sir. Sir, is it visible?
Yeah, it is.
Okay.
And go ahead, please.
Yes, thank you. So greetings everyone, I'm Nazia Parveen and I'm excited to present our study titled A Comparative Study of Light Pollution Effects on Moths Using Machine Learning and Explainable AI. My co-authors are Anika Tasnim, Mushbika Jannat Prishti, our supervisors Anajat Alim Rasul sir and Dr. Munima Hoffman. This collaborative research explores the intersection of ecology, machine learning, and explainable AI, aiming to understand the impact of artificial pollution on moths. Artificial light pollution is a growing environmental issue caused by constant illumination from streetlights, businesses, and homes. While it facilitates human activities, it disrupts ecosystems affecting animals, plants, and even humans adapted to darkness. Our study focuses on moths whose communication, foraging, mating, reproduction, and migration are particularly disrupted by artificial light. These disruptions have cascading effects on population dynamics and ecological balance. We investigate how moths are drawn to different wavelengths of light and how that impacts their foraging behavior. Artificial light pollution is an environmental issue caused by constant illumination from streetlights, businesses, and homes. As nocturnal insects like moths are lured to artificial lights, the consequences can be fatal, and this has motivated us to do the research and find out how they are affected by artificial light. So methodology here, we have first collected a data set, then we have done some data pre-processing, and for balancing the imbalanced data set, we have used borderline smart tomic, and then we have done the training using machine learning models like decision tree, random forest, XGBoost, KNN, and then we have applied the explainable AI methods like LIME, SHAP, and ELI5. Our study builds on some prior research, like this study here shows the artificial. This study here shows that uh, Ponometer's cag- uh, Cagney show that artificial light disrupts their feeding and calling behaviors. Another research here shows that highlights how light pollution affects the visual ecology of pollinators like hawk moths. And the findings of this research, titled Streetlight Affects Moth Orientation Beyond Flight-to-Light Behavior, show for the first time through experimental research that streetlights fragment landscapes, and they also show that light pollution affects moth movement patterns beyond what was previously thought to be the case. This could potentially hurt moth reproductive success and impair a critical ecosystem service. These findings underscore the need for deeper analysis using data-driven approaches. So the dataset we have used is named Data Moth Foraging. It contains 6,900 annotated data points and 8 characteristics of moth behavior, and it consists of 4 different types of moths: Mimostra brassicas,
related to your work. The first one is from where you got the data, and what the data sample exactly, what inside.
We got data from online website actually, and the data set has 609,000
No, no, I'm
6,900
not asking
connected.
this one. I got this one. What is the data sample actually? It's a CSV file, it's an image, it's a, what it is?
It's a CSV file, sir.
Okay, so there are multiple columns inside, right? And you have the values.
Yes, sir.
Yeah. So what is the main purpose of this? Who is going to use this research? And what are the purpose for that?
Sir, we are going to use this research. The purpose is, sir, to show that how artificial lights are affecting the ecological balance ecological balance, and we hope that someone who's interested in uh, ecology, or someone wants to do research on environment, he can use that paper. Our research work can be used there.
Do you believe the data set that you are using that is correct or incorrect? It is a verified data or not verified? It's a system generated
Actually,
data.
sir, there was scarcity of proper data set here in this field. Actually, there was really scarcity of proper data, and we couldn't apply. It was hard to apply all the models in the due to the scarcity of the data set.
No, scarcity is a different matter. The 6,900 samples is sufficient for the machine learning model, I think. But do you have gone through who actually uploaded this data? What is the source of this data? The value inside data is properly labeled or not? Are you getting my point?
Yes, sir. We have done some pre-processing also here in this data. So there are some features that were not important in our
Mm-hmm.
data set.
Can you show
So,
one sample of the data that you have used for this research? Can we see
sorry, sir.
a sample of data? Do you have
Yes,
the
sir.
file, data file?
Yes, sir.
Yeah. Can you just show to us?
Okay, sir.
The data is look like this.
Okay, sir.
Nazia ma'am,
Yes.
may I know the main contribution of this work?
Sorry.
May I know the main contribution of this work, ma'am?
Our main contribution.
Yes, ma'am.
Our study has looked at the feeding habits of adult moths exposed to artificial lights, and moths are attracted to. Sorry. We conducted a detailed analysis of the effects of light pollution on moths using these machine learning algorithms, actually, like how they are affecting. Like we have found that they do good in foraging in the darker places, and using those ML models.
Okay. We are waiting to see the data samples, ma'am.
Okay, okay.
Yes.
Sir?
Go ahead. Your voice is also lagging.
Oh, sorry, sir.
Continue, please. Share your PPT.
Okay, thank you, sir. Centralized data without sharing the raw data. Fed average algorithm, which is used for the better protection rules. It ensures the privacy and scalability across the institutions. This is the methodology of my progress, data processing, model architecture, federal learning framework, training, data pre-processing. Data pre-processing to capture the characteristics of drugs and their actions. Synthetic database are created. Every database is tailored from a particular client that used for the federal ranking architecture. The characters of the data sets, each data points have 10 characteristics that each indicates a different paramorphical properties that is important to forecast interaction. Um, uh, the targeted variable is interactions. So the binary variables are used 0 and 1. 0 denotes the negative, which means existence. 1 denotes the positive progressing. Pre-processing. Pre-processing normalization. Pre-processing, we use the normalization function. Normalizing using the Z-score method. Z-score, which is normalizing the process, data pre-processing used to transform the feature of the data set into a standard range of scale. Of non-linear features, multiple dense layers are with the employed with oral rule activation. Batch manipulation, the incorporation of the batch normalization layer followed each dense layer in order to enhance the training stability and migrate the risk of overfitting. Dropout layers to further
We know,
learns
you can
the
skip.
changes. Okay. Okay.
Rasi, you can skip those things, basic things. You directly go to the outcomes, whatever you
Okay.
got.
Okay, fine. The outcomes, the result of the progress for from of the point from the round first to 0.85, and in the final round it's 0.90. This is from 0.8. Collecting the simplification of perfect of real positive cases. Calculator means sorry. It's code to 0.90 to 0.94, which average of 0.92, with highlighting the model step to discuss between the positive and negative cases. This is the time stimulations of the progress, which takes for each progress. Then is the comparison of the existing model and the proposed model. The proposed model gives the from the round 1 to round 50. This is the graphical representation of the comparison of the existing model and the proposed model. The conclusion with synthetic data, the improvement improved federated learning framework for drug detection shows this. The environment gives the accuracy of 0.89, precision of 0.91, recalls of 0.87, and accurate approach of 0.96. The accuracy results invest the involves the application of this methodology to real-world dataset to verify the efficacy programmatic context. In future, it includes the real-world database, domain-specific features in incorporation, and scalability enhanced to broad connectivity. This is our reference I took that. Thank you. You can ask for the questions, sir.
Thank you,
Thank you.
Rasya, for the presentation.
Thank you, sir.
One thing I am not understood. What is the drug interaction means? You are predicting, right? Drug interaction.
Yes, predicting. Predicting the drug interaction with the human usage, sir. From how many we can interactions with the drug levels of the humans taking, sir.
Any example you have? Any real-time example can we? Yes.
We can wait, sir. Two minutes, sir.
Yeah, take your time. This is the problem with research actually. We are not understood what is the problem, and we are ready to apply the models.
When we can take the protein binding efficiency, we can take when we take too much of things, toxicological production, risk of taking the gastric irritations and bleedings. When taking too much of paramedical drugs within us.
So how you can decide this is 0 or 1? Means the interaction is positive or negative. How anyone can say?
The level with the level of the intakes, which just comes with the data samples. We cannot use the data directly for the privacy concerns. We are just getting the progress.
The privacy is different, but this is a medical related research, right?
Yes, sir.
So each and every parameter must be correct. Privacy means what? You can remove the name of the patient and their details. That only the privacy is over, right? If the patient name and their details is going to be removed, their identity is going to be removed, there is no much, nothing else after that, right?
Yes.
Yeah, so the data, if not real, you have said that it is a synthetic data.
Yes, sir.
You have not revealed the feature's name, what features exactly, and how it can be decided as a positive interaction or negative interaction. Is there anyone from your group, medical expert?
No, sir. We are just collecting with the students.
This is a serious concern. Whenever you are working with a medical problem, now I think you have to consult with whether your data is correct or incorrect. This is my personal opinion. I think I believe medical research is something like sensitive, so your outcome is going to be must be verified in a proper way. So take care of those things in the future if possible. Okay. Otherwise a good one. That's all from my side. The team, if you have any other questions, please proceed. The team ICADCML, from your side, any question? Okay then. Thank you.
Thank you, sir. Thank you for the opportunity.
Now paper number 16. I think, are you there? Paper number 16, 16. Is there anyone who have not presented? Is there anyone present here who have not presented? Seems all have done. If your presentation is completed, participant, you can leave the meet. Thank you for presenting the work and wish you all the best and Happy New Year too.
Happy New Year, sir. Thank you.
Okay, thank you, Dr. Roy, for chairing the session, and thank you, participant, for joining the conference. So hope we will see you next year with the conference again. Thank you again, and Happy New Year to everyone.
Thank you. Thank you.
Thank you.